Hello students. Now again I am going to solve some question on simple iron motion which are important and we will feel difficulty in solving them. Here there is question: two simple harmonic motions are represented by y1 equal to tan sine 100 pi t plus pi by 3 and y2 is equal to tan bracket sine 100 pi t plus root 3 cos 100 pi t. So you are asked what is the ratio of amplitude of y1 and y2. You are asked what is the ratio of amplitude of y1 and y2. So y1 so it is clearly 10. Amplitude of motion represented by y1 equal to this is 10. But here this motion y2 motion y2 is equal to 10 y2 10 bracket sine 100 pi t plus root 3 cos 100 pi t. We can write it as tan sine 100 pi t plus tan root 3 cos 100 pi t. So y2 is vector sum of two motions. I have told you many times in equation y equal to a sine omega t. This argument of sine tell you the phase which gives the direction. Which gives the, this is very important, dear friend, while studying the wave motion. And wave, without wave physics, if somebody says that I know physics and he does not know wave, then he does not know physics. White omega t is the phase and gives the direction. Here, I can write like this: tan sine 100 pi t plus tan root 3 and sine 100 pi t plus pi by 2. So that way this motion, yani कि this one and this one has phase difference of pi by 2, means this motion leads in phase by 90 degree. So amplitude has direction in one, it is at 90 degree. This amplitude 10 and tan root 2 has angle between them 90. If it is 10, then it will be tan root 3 and the resultant will be like this. So amplitude of y2, amplitude of y2 equal to amplitude of y2, that is a2, I write here as under root tan square plus tan square into 3, it is 400 equal to 20. So a1 upon a2, a1 is 10 and it is 20, 1 by 2. I have read the solution of this part, how to represent this motion. Actually, you have learnt law of parallelogram. Here y1, y2 are called displacement from beginning position, and displacement is vector quantity. So we are adding the two vectors here. These are two vectors. One vector is this, another is this, which has been written as the angle between the direction is pi by 2, 90 degree. This is the amplitude, one, and this is other. People have solved this by applying different method. But I feel this is the simplest solution to understand basically what is phase and what is the meaning of phase. People don't understand meaning of phase. Dear friend, after long experience, I got all these things. I was totally unaware of such facts. And when I started reading the books, I found many problems. Then I said myself, and I suppose that these questions are for students by a teacher generally. That inspired me to do such questions for students. So I hope you will understand my aim and try to understand, dear friend. I hope you will like my attitude. Now there is another question here. Again, there is another question. The displacement of particle. I am just for sake of revision, I am telling you. The displacement equation of particle SHM is given by y equal to 0.2 sine 50 pi t plus 0.01 meter. Then displacement in meter, time t in second here. 50 pi t. Y displacement in at time t. Calculate as number one amplitude. Amplitude, comma, time period, maximum velocity, and displacement. Here I am doing this question for this part. Displacement at the starting. At the start of motion. When motion started taking place, what was the displacement? So this is the equation of SHM. General equation, 4 equation y equal to a sine omega t plus phi. So this equation we can write here, given equation 0.2 sine 50 pi t plus 0.05 pi. 0.5 pi, sorry. 50 से मल्टीप्लाई करना भी होगा ना, तो 0.01 into 50, 0.5, yes, और पाई भी है. We compare it with this, तो amplitude 0.2 meter, omega 50 pi, t equal to 2 pi upon omega 2 pi upon 50 pi 1 upon 25 or 0.04 second. Then you are asked angular maximum velocity. You know V maximum is equal to A omega. A is 0.2, omega is 50 pi. So it is how much? 10 pi. 0.20 10 pi meter per second. Pi 3.14, so 314 31.4 चलेगा अभी. Now you are asked displacement at start of motion. स्टार्ट ऑफ मोशन के लिए क्या होगा? मोशन स्टार्ट्स at t equal to 0. So y equal to 0.2 sine 50 pi into 0 plus 0.5 pi. It is 0. So 0.2 sine pi by 2 है sine 91, so 0.2 centimeter. Mean at the start motion start from extreme point, it was at extreme position, amplitude position थी. Yes, I want to solve two questions for you, just for sake of practice, because these questions are generally asked and our students fail to attempt these questions. Here there are two springs, a mass M attached. Their spring constant are K1 8 Newton per meter and K2 here 2 Newton per meter. Mass M, this M is equal to 0.1 kg. As students see, because they don't practice themselves, so they feel a very difficult question. What is asked here? Calculate the frequency of vibration. If body displaced, then frequency of vibration n. So here too, if this spring compressed, it will extend. So equivalent spring constant here, equivalent spring constant K is equal to K1 plus K2. So it is 8 plus 2, 10 Newton per meter. Omega equal to under root K by M. K is 10, M is 0.1. So it is root 100. 10 per second is the, and we know 2 pi n is equal to omega. So n equal to omega upon 2 pi. 10 upon 2 pi. 5 upon pi. Per second you can write here. So this way हाँ भाई, वो पाई की वैल्यू छोड़ के हुआ है, कोई बात नहीं है. 5.3.14 किया है. Another question of spring here again. Please watch the video very carefully, patiently, sit alone. No disturbance will be there. Only then and realize what you are doing. Now, here are two springs, K1 and then K2 and then mass M. Here K1 100 Newton per meter and K2 is 400 Newton per meter. Mass M 5 kg. Again you are asked here time period of motion. I have proved that when spring are coming series, it is K1 and K2. So equivalent spring constant K is equal to K1 K2 upon K1 plus K2. 100 into 400 upon 500. 0. It is 80 Newton per meter. So time period T equal to 2 pi under root M upon K. 2 pi under root M 5 upon 80. It is 2 pi under root 1 by 16. 16 5 by 80. So 2 pi by 4. Then pi by 2. 1.57 seconds. Though these questions are simple, but I have noticed in exam, students do not try these questions. So dear friend, be very sincere and work accordingly. In my previous videos, I have solved many questions while teaching the physics of simple harmonic motion. Please see them also. Here there is a question based on that. Calculate the percentage change in periodic time of simple pendulum if length of pendulum increased by 4%, mass of the bob increased by 30%, oscillation to decrease by 50%, etc. So time period of pendulum T is equal to, I am telling verbally, time period of pendulum 2 pi under root L by G. Now listen what he is asking. If length of pendulum is increased by 4%, then what is the increase in time, percentage increase time period? If mass of bob, pendulum pendulum has a bob of certain mass, length L. So mass is not there. So whether you increase, decrease mass, so time period does not increase or decrease, no change. If amplitude is increased, amplitude is not in this. So on changing amplitude, time period does not change theoretically. And then he asks you, okay, if pendulum is taken to a place where value of G is 0.8% more. तो ये क्वेश्चन है, I have solved you simply for length but time बराबर 2 pi under root L by G. If we increase length say by delta L, so time period will increase, so T plus delta T 2 pi under root L plus delta L upon G. I am telling the technique so that you can solve. You are asked here delta T upon T %. तो डिवाइड दिस वे बाय दिस, t plus delta t upon t, everything that get cancel, only here L plus delta L upon L. It is 1 plus delta t upon t. It is 1 plus delta L upon L to the power half. Delta L upon L is 4%. So 1 plus delta t upon t is equal to 1 plus 0.4. By 4% means 4 upon 100. To the power half. Binomial exponent says that if x less than 1, so 1 plus x to the power n. I have told many times. Apply directly here. It will be 1 plus half of 0.4. This one cancel. Delta t upon t equal to 0.2. So nearly it is, because there is approximation here. So exactly it is not, but nearly 20%. If g increases, L remains same. So g increase, time will decrease, so you will have minus t here. And same way you can proceed. Thank you. I will be trying more numericals for you for simple harmonic which have been asked in competitive exam, and then I will be telling you later the free vibration, force vibration, damp vibration, resonance. ये बड़ा important टॉपिक बचा हुआ है अभी. Thank you. If you like my video then like it, और पहले लाइक कर लिया करें, फिर भूल जाते हैं लोग बाग. Ask your friend to subscribe channel. Thank you.